All right, so here we have three separate terms. And so just like we would differentiate each of these individual terms, that's the same thing we're going to do with integration. So we are going to simply integrate term by term. And so we will think about what is the integral of the 6x squared first, then think about what is the integral of the 3x dx, and then what is the integral of the 3 dx. Now, you don't need to write this down, you guys. It looks like it's way more complicated than it needs to be, but I'm just trying to emphasize I'm integrating this term, and then integrating the final term. So we'll just kind of put that highlighter over there and focus on term by term here. So if I look at the first term, the 6 is going to tag along. And then for the power rule, I will do my add 1 to the exponent, divide by the new exponent. So that will give us x to the third over 3. Then I'll look at my next term. So my next term is this negative 3x. Remember, I am using the power rule there with the negative 3x. It is raised to the first power. So I will have negative 3x. 1 plus 1 will give us squared over 2. And then our last term is this plus 3. Remember, the plus 3 is a standalone number, but with antiderivatives, we add on to it. So that plus 3 will become a 3x. And then we add our plus c. And that is our final answer. Of course, you can simplify and you want to simplify. The 6 over 3 will give you a 2x cubed plus the 3 halves does not simplify, and then the 3x plus c. Now, one thing that I do want to mention that comes up from time to time is people are like, why don't I add like a plus c here, a plus c here, and a plus c there? Because I have those three separate terms. Just so you know, like if you add the plus c, plus c, plus c, remember what plus c represents. It represents this any arbitrary number. So if you take any number, arbitrary number, times it plus another arbitrary number, you are just going to get one big arbitrary number. So you don't need to be writing three separate plus c's. You'll only write one plus c per problem or per equation, I should say, or line type of thing. And that's just because the plus c represents that arbitrary number. You do not need to write multiple arbitrary numbers.